All right, I want to take some time to explain how a computer works. And my purpose here is not going to necessarily be to have every single detail 100% correct, because there'll probably be some mistakes. If you catch some mistakes, feel free to comment what my mistake was. But it's really just to give a general overview of computers and to include some things that I think are often left out. So there's a there's we'll say that's ROM. We'll say this is RAM. This is going to be a CPU, GPU, some hardware, probably like that, and like that. That's good enough. So let's label some stuff here. So we have this is ROM, this is RAM, this is your CPU, and this is your GPU. I'm not super familiar with the GPU. It's going to be kind of similar to a CPU. It performs calculations. It's just going to do different calculations because, well, ones that deal with graphics because it's designed in such a way that it's better at processing those kinds of calculations. So I'm kind of going to ignore it though for this because I'm not super familiar with it. But inside the GPU, you have the arithmetic logic unit, and you have a bunch of registers. Oops, registers. Then let's say if this is a, let's put it over here actually. This is a mouse. You could have a lot of things. You could have a screen, you could have a keyboard, you could have speakers, you could have, whatever. Actually, well, instead of a screen, let's make that a keyboard. I just won't put the others, just know that they're there. Uh, and then you have also a bunch of types of cards. So one of those will be like an Ethernet card or network card. I think it's called a network card. Network card. There'll be other cards too. Um, I'll just put this one on there, network card, which you can almost read. Yeah, that's as good as it's gonna get. Okay, so, and then these are gonna have, so the one I really want to spell out is the mouse because I'll use that for my explanation, but it's gonna have left button, wheel, middle button, right button, and laser. The keyboard will have just tons of buttons, and the network card, I don't know exactly how they work, but it's gonna have a MAC address, it's gonna have a IP address, it's gonna have a, what else? Some other things too. Anyway, that's good enough for now. And then in the CPU, then we have these things called registers. I'll use a different color. So this is inside the CPU. There are these things called registers. I'll pretend that's straight. Register. There's just a ton of them. We'll just leave it at that. I just drew however many I happen to fit on there. Um, so registers. Now, and I can put an arrow over to there. Those are the registers. Now we have a lot of connections between the devices, and this is one place where my graphic will most certainly be incorrect, but it's just to show that there are connections, not necessarily how the connections go. So there's going to be some connections, I think, between probably, say, the CPU and the ROM. Maybe the ROM and the RAM, I'm not sure. Definitely between the CPU and the RAM. I think the CPU has to connect to just about everything. So probably the CPU and the GPU, or maybe there's a graphics card in between here and it goes graphics cards, GPU. Again, my point isn't to get every single detail correct, just to show in general. The CPU somehow is going to go to the mouse. Maybe it's not a direct connection. There might be some stuff in between, but it's got to communicate to the mouse. It's got to communicate to the keyboard. It's got to communicate to the network card, and so on. So you kind of get the idea here. And then what happens, uh, what am I missing here? So, and actually I'll draw the arithmetic logic unit inside the CPU, just because it'll fit, I think. And let's actually move it down because I'm going to want to put something else there later. And arrow, this color. So this little box here just represents your arithmetic logic unit. Now, the arithmetic logic unit is made up of transistors, which I don't know, I'll use a symbol. So there's these transistors. Oh, what do I have it on? Yeah, I have it on that. That's not what I expected that to look like. Let's not use that one. And I just deleted something on accident. Okay, arithmetic logic unit right there. And save this. So we have, what's I doing here? Let's do transistors. So this arithmetic logic unit is made up of transistors, which I'm just going to generically draw them as triangles. And I'm not even going to worry about putting the right amount, but let's say that you put a couple together, in a different pattern. I don't want to get into this so much because this will make the video a lot longer. And so on. There's 3 main patterns. There's probably a ton of other patterns. And so these are going to be arranged in such a way that when you put them together, they could make what's called an AND gate, an OR gate, or a exclusive OR gate. And once again, there are others, but that's just 3 basic ones. And what happens then is the AND gate, you give it 2 inputs, and the output will be true if both of the inputs are true. The OR gate, it will be true. You give it 2 inputs, it will be true if either of the 2 are true. The XOR gate will be true if only one of the 2 is true, but not if both of them are true. And then you can combine those in such a way to get these 2 components called a full adder and a half adder, which I'm going to end up probably deleting all this because this is a little bit lower than I want to go, but so that would be a full adder, and that would be a half adder. And then you can also arrange the transistors in such a way that they are used for memory so that they act just as switches. So the switch will store an on or off state, but the memory can also exist in other kinds of physical ways as well besides transistors, but that is a possible way that it could exist. Yeah, so you combine together transistors or maybe some other components to make basically a state that shows an on or an off position, and that forms all of the memory. So the memory, RAM is memory, ROM is memory, and the registers are also memory, which are inside the CPU. And then the instructions, the decisions are done by AND gates, OR gates, exclusive OR gates, half adders, full adders, and maybe some other kinds of logic gates that would be what is inside the arithmetic logic unit to do the calculations, okay? So that is a real quick rundown of the hardware. Now, when you program, if you program at this low level where you're thinking about the hardware, where you're thinking about registers and CPU, you're most likely using a programming language called assembly. And assembly language, there's actually there's a different assembly language for every chip, every CPU you would buy because it's specific to the CPU. And you could also be using C because C allows you to interact directly with assembly. There are also some other options too, such as Rust and some others. They're less common, so I'll just keep it assembly in C. And then let's see. So what happens at this basic level and where you might be thinking about assembly language, where you're going to be thinking about the CPU, the registers. Let's take the mouse, for example. I think I'll use orange this time. So there's going to be an address that represents the left button of the mouse. That shows up okay. And what happens if you want to interact with the mouse, you have to give an instruction to the CPU to read that address and put the value of that address, whether it's clicked or not, into a certain register. Then some other code will come along and decide what to do with the information from that register. So what to do with whether the button's clicked or not. Same's true for every other thing over here, for the buttons on the keyboard, for the wheel. The wheel, it it cycles, but it's roughly the same in principle. Uh, the middle button, the right button, and somehow for the laser, although I don't know exactly how lasers track the position of the mouse, but it's more or less the same. There's going to be some kind of address, and it goes and it pulls the information from that address um, to, to determine the state of that requested uh, input. And yeah, so that's registers, that's assembly. Uh, the only other thing is, so assembly, so inside of RAM and ROM, which this I'll write in RAM just because I'm going to end up filling up ROM later, but I'm going to kind of mix these two up, so don't get too hung up on whether something is RAM or ROM. I'm not 100% sure when it uses one or the other. That's not going to be the point here. They're both memory, and we'll just leave it at that for right now. Um, I think there's also maybe some small amount of memory on the CPU, and in fact, I think like the GPU, the network card, they probably also have their own memory too. But for simplicity's sake, we're just going to say memory in general, and most of the time I'll just talk about ROM, whether it's really somewhere else or not. So um, I think that the ROM will be like sitting there, and then it loads stuff to RAM when it's like actively using it, and then when it's done using it, it sits in ROM. I think that's roughly how that works, but it's not so much where I want to go with things. We'll just talk about it as if it's just memory in general. And then, but I do want to show, so inside of the RAM, everything is just ones or zeros. Technically, it's high voltage or low voltage, but we often represent those as ones or zeros. So there's going to be, 1, 0, 0, 1, 0. Let's make it a byte. 1, 2, 4, 1, 2, oops, 2. How many is that? 1, 2, 3, 4, 1, 2, 3, 4. There we go. So there is a byte. It's 8 bits. And what you have then is these registers over here will have a certain amount of bits that they want to handle. And it would be, is it 32 bit or 32 byte? 32, I think it's 32 bit. So often you have 32-bit architecture or 64-bit architecture. That's just the size of each register, which is the memory that is actively being used on the CPU. So I guess I am talking about the memory on the CPU. It's the registers. Um, so yeah, so the assembly to get between, so just to talk about the programming language, so the computer stores its information in ones and zeros, which a single digit is a bit, 8 of them is a byte, and then so on. For there's other names besides that, but we'll just talk about bits and bytes for right now. So yeah, so in the assembly code, you're going to have, let's, again, the number of bytes is not the important part of what I'm trying to say here. I'd have to look it up to know the exact amount of bytes, but let's just say that, if you have an assembly, I guess I think you would say this is probably 16-bit architecture, what I'm about to say, but again, that's not my point. But let's say there's an assembly, you have 16 bits, and that represents some information. You may have so that the first byte, so the first 8 bits, would be what's represented by the opcode, and opcodes look like something that's sort of intelligible. So it'd say like move is 1, add is 1. Those are the 2 I can think of off the top of my head. Um, and then they're followed up with some address information. So that would be like EA. What can I type there? What the E? I think I glitched it out here. Okay, EAX. I think you usually use, I don't know, I'll use capital letters, and then say 1. So again, this may not be perfect assembly example, but I believe what this would do, if I wrote it out correct, it's going to take the numerical number 1 and move it into EAX, which will be a certain register. And then you could also have it from there. Once it's in the register, you could tell it, now move it to this place in RAM, or maybe ROM, or both. Again, I'm going to mix those up. But move into this place in long-term storage. Or you could have it, okay, now that you have this value in EAX, move it to the the monitor, for example, as an output for the monitor. One of the LEDs, for example, or however exactly it sends information to the monitor, or move it to the speaker. All those different kinds of things. Move it to the LED on your computer that says, "Hey, I'm on right now," for example. So that's what they look like. That's assembly. Assembly directly translates to machine code, which would be what this is called, the ones and zeros. Um, because this address will have a numerical value in binary. The number 1 will have a numerical value in binary, and the instruction MOV will have a numerical value in binary. So there's a direct correspondence between assembly and machine code. It's just that this is easier to read than a bunch of ones and zeros, which technically it's not ones and zeros anyway. It's actually high and low voltage, but usually people don't even go that far down. So yeah, so what's next? So that's at the really low level assembly. C then is you're going to have, before I get to C, we need to talk about some really key things here. So I think what color, I like this orange color. Use this orange color. So you have this thing, this important set. So almost everything else that I'm going to talk about and almost everything else there is to say about a computer is actually software. The hardware is not nearly as complicated, even though I skirted over some things, mixed a few things up, and left quite a bit of pieces of hardware out. It wouldn't take that much effort, I don't think, to go over the rest of the hardware. Whereas to go over, quote unquote, the rest of the software, you never finish that. There's so much software, it's crazy. So now I'm going to start to talk a little bit about software. So something that I think is important to remember is software is literally just uh, just chunks of memory. Okay, so in the CPU, well, actually, I'm going to put this in the CPU. I don't know for sure if it's in the CPU or the ROM, but I think there's a special place on the CPU for this. So that's where I'm going to put it. If I'm wrong, I apologize. But the point is, it exists wherever it is. So there's this thing called a BIOS. Now, BIOS is just, again, it's software. It's ones and zeros, it's instructions. They sit in a certain place. They're programmed, I think by the manufacturer. They're programmed before you buy it anyway. I think it's the manufacturer of the CPU. That's why I think it's on the CPU. But anyway, wherever it is, it's special instructions that tell it what happens when you power the device up. Because if you give power to a CPU without a BIOS, it would just sit there. It wouldn't do anything because it wouldn't know what to do. So the BIOS is the most basic instructions about startup. It probably does some other stuff too, but again, I'm going to skirt over a lot of stuff. So one of the things that it does is basic instructions for startup. So one of the things that it does then is it has to look for the operating system. And so now I'll start to let's use blue. So the operating system, we'll put that, gonna need a lot of space, I think. Probably, if it's Windows, there's gonna be a lot of space there. There's this thing called an operating system, and it has some important parts of it. I'm gonna put two, there's probably a ton more. Again, I'm not an expert on every single thing that I'm gonna mention, but there's this thing called an operating system. And specifically, so when you start up your computer, the BIOS goes and looks for this special piece of software that this one would certainly be in the ROM. This has to be like hard coded, sit there. It shouldn't really change or move. It's maybe some pieces of it will change, like parameter settings, like as in personalization settings, but for the most part, it just stays the way that it is. It's very important that it stays the way that it is. And so the operating system has a couple of pieces. I know for sure one is called a kernel. There's another one that exists that I'm not sure the name of it. I'm going to call it a scheduler. That might be right, that might not be right, but the function, that's what it does function-wise, scheduler. So I'm going to call it that. So the kernel, so the BIOS will go look for the operating system. When it finds it, it loads it. I think it loads it into RAM. I'm not really sure, but it does. It says it like activates it. Well, I'll put it that way. I think that means it loads it into RAM, but I'm not 100%. It seems like it couldn't load the whole operating system. So anyway, it activates it. And then one of the things that it's going to do is the kernel is the part of it that like runs the main the main things. So the first thing we'll do is activate the kernel, which probably means it loads the kernel into RAM. Again, that's not so much the point of my video is to get every single detail down, but so it runs the kernel. Uh, so we have the BIOS, we have the kernel. Now the next thing, again, I'm trying to get back to explaining C here. Before I do that though, I think we're ready to add in some applications. So I'll make other like user applications. Well, actually, before I add applications, let me create a couple things. Actually, I think these are part of the operating system, so I'm going to put them there. So there's files and folders. Uh, there's going to be like command prompt, which didn't fit on there. Um, some other really core types of software that will be inside of the operating system because they have to be for it's so basic to what an operating system is. Uh, Now let me add some like user applications. I'll go back to orange for that. So you might have user applications could be, get back to the square one. You might have something like let's make that one, that one, that one. I'll just make 3 for right now and then we'll see if I decide to make some more. Um, so we could have a text editor. We could have a browser. We could have a video game. And that's good enough. There's tons and tons of other types of software. And text editor, so that's a basic type of software, but there's many different ones that you can have. For example, you could have Microsoft Word, you could have Notepad++, you could have Google Sheets, you could have Atom, Notepad, just tons and tons of them. But they're all text editors, so they're all going to have a lot of things in common about the way they're programmed and the way they function and flow. So that's one type of software. Another type is a browser. Again, you've Google, you have Brave browser, you have DuckDuckGo, you have Edge, anyway, whatever else there is. You have all these different kinds of browsers. And once again, programming wise, they're going to have a lot of similarities between them because they do the same functionality. Video game, and so on. You get the point. Now, now I'm ready to bring back in C. So what happens is these are user programs and they don't have the same permissions as the kernel. So what happens is when you run your code, the CPU is just taking chunks from maybe from RAM or ROM, definitely from RAM. I'm going to say from RAM because I think that's how it works. So the CPU is taking little chunks of memory from RAM and little chunks of information from the mouse, the keyboard, the network card, the GPU, and other boards and such. It takes those, it loads them into registers, it runs the information in those registers through the arithmetic logic unit and performs calculations on them and spits out the results of those calculations and now stores the results of those calculations in, again, it could be in an output like a monitor, it could be in several other places. It could go to the network card. It can certainly though go to RAM to fill back in to your program that you made. Okay, but the memory is not all the same, and there's actually differences. I just came across the word recently, so there's virtual memory, and for the life of me, I don't think I'm going to be able to remember the other kind. I'm going to call it direct memory, but that's not what it's called. I just forget what it's called. So uh, virtual memory has a certain type of access, and there's going to be other levels and layers of access too, I think, but this is just kind of, again, very basic, very rough explanation. So the virtual memory here, when you use like the text editor, let's go with the text editor. The text editor definitely needs to interact with the mouse, the keyboard, and the screen. I didn't draw the screen down here, so we're going to ignore that. When the computer is running the part of the application for the text editor, parts of the program, parts of the ones and zeros that are inside the ROM here for the text editor, I think then they will be loaded into the RAM, and but the there are parts of the operating system that they interact with. So you can't just like run the text editor directly without the operating system. And part of the reason is, so these orange ones here, text editor, browser, game, they do not have access directly to mouse, keyboard, network card. In fact, I don't think they have direct access to registers. Um, what else? Other things, the GPU. What happens is they like request permission through the operating system, and the kernel is what has access. So when you program, so I could put a label here that says assembly, which assembly is relates to everything. C then is usually what you're going to use when you develop drivers. So I could also put those. I don't think those are actually part of the operating system. So, but we'll put them right here, device drivers. So you're going to have a driver that tells this how to interact with your brand of mouse that you have. I don't know what all's in a driver. I've never seen one, but it'll probably have to have like address type information for the different buttons and the laser, and I don't know, maybe some information that tells you like when the wheel moves, how far a click on a wheel represents for how far it should move on the screen. With the laser that tracks the position, some information about how, whatever that laser's seeing, I'm assuming it's triangulating this position, but I'm actually not sure. We go with the wheel one. The older styles had a wheel on there. As that wheel moves, how much wheel movement represents how much movement on the screen, for example. I assume the driver's going to have like that type of information in there, and probably some other stuff too that I didn't think of. So usually when people program device drivers, they use C, um, or one of the other versions of like Rust, or I forget, there's other ones. So anyway, my point was to say the operating system is what actually has access to those. The next thing is typically that these orange ones, these I guess user privilege, I think is how you'd say that. These certain privileged ones here do not have the ability also to access directly any memory anywhere, I don't think, or at least normally they don't in RAM, in ROM, or in the registers. Again, the memory locations are assigned by the operating system, so actually that could have been another functionality that I wrote over here, um, which I don't know what that's called. Well, I'll call it memory assignment. And this should be in a box, but I don't have any more room if I'm keeping consistent with my stuff there. So that will decide where the memory is, because as you fill up these ones and zeros, you have these lines and lines of them. So actually we can just repeat this here. Ah, shoot. There we go. So let's put a couple more of these and kind of fill this up. So this is, once again, the ones and zeros, those exist. That's what RAM, ROM, the registers, all the memory looks like that. I'm just going to put it here for illustrative purposes and not put it in the other places, even though that's what's being used everywhere. What happens is if you allowed the machine to just write line by line, it's going to end up running into problems when, let's see how to say this, you might end up with gaps and empty spaces in these sets of ones and zeros in these rows. So what the operating system actually does is say this row might be the first line of your text editor program. Then the second line of your text editor program might actually be here. And I'm not sure if they have to go sequentially. I assume not. So maybe your third line is here. Maybe this is a completely different program, and maybe this is a completely different program. And so sequentially, as far as the text editor logic is concerned, they're sequential. But as far as physical memory is concerned, they are not sequential because that would not be the most efficient use of the space that you have. So that's another function, important function of the operating system. We spoke pretty heavily about the kernel, the memory assignment part of it. Another important part is the scheduler, And again, there probably are things I'm leaving out of here, but these are just the three that came to mind as I'm trying to explain how a computer works. The scheduler will determine you don't typically have your computer just running text editor code and nothing else. That's not the normal way that a computer works. So you may have the text editor going, you may have, like right now, I have Paint going, I have YouTube going, playing music, I have OBS going, recording my video, and in order for it to run all those at the same time, it has to jump between them. It runs a little bit of code from text editor, then a little bit from browser, then maybe a little bit from text editor again, then maybe a little bit from the game. Actually, I should have had that the other way. The game would be the one that would need the most to be used to be refreshed the most often. So if I were playing a game right now, it would go probably check the game, check the browser, check the game, check the game, check the game, check the text editor, check the game, check the game, check the browser, check the game, something like that. Anyway, um, so that's another important thing that the operating system does. Now, getting back to how computers work. So the reason there's this word down here that I can't remember, virtual memory is what you call the memory access being accessed through like a user program, like an application, a process would be what it's called in operating system world, and that's not sequential like I showed here. There's another name for the type of memory that how it actually exists and how the operating system has the ability to access it that way, as in like access this line, then this line, then this line. And that's got a different word. I call it a direct memory. I'm sure that's not the right word. I just can't think of what it is. So now let's dive deeper into something that we have, any one of these things here. So let's pick something. I'm actually probably going to pick a console project because that's the thing that I know the best about. So I think that's what I might be able to talk the most about. So let me see if this purple color shows up. I haven't used this yet. That's not too bad. All right, so now for this, I could program in any number of languages. So I could do C sharp, I could do C++, I could do oh, what else? Java, Python, and the list goes on and on and on and on. They all more or less look the same. The vast majority of them, it looks like text, and they even use a lot of the same symbols and styles between them with small variations between them. So I'll pick one. Python would be better, but I've recently been working a lot in C sharp, so I'll try to pick that. I'll probably get some stuff wrong, but again, it's for illustrative purposes. So just to kind of give the picture is to show how the computer works, not necessarily how to code in C sharp. So um, so let me take some space here. Where'd my, let's do another, I don't know, let's just use a different shape here. Let's kind of just cover up some of that. I think I want to make that even bigger. So we'll kind of make it go over the memory. So if I were to fit this into my stuff that I have going on, um, I want this to be inside my ROM and or my RAM. I just don't have the space to do that and then put anything useful inside of it. So imagine that all of this is actually just ones and zeros inside ROM and RAM. And what happens is, I should have had that fill in, but let me delete some of that space out there. So I want to write in here. Okay. So let's say I have, I'll probably have to try to go with a console project because I don't know real well. Um, what happens is I have a thing called a compiler, which once again, important to stress and remember, a compiler is just going to be an application that's installed in the ROM. So we'll put that over here. I'll put it orange because it's just like the other ones below it. A compiler. In fact, in this one, I'm going to need a C sharp compiler because this is going to be C sharp. So we'll put that, I guess I'll write the code in orange. The orange is a little easier to see. So this is C sharp. And I don't want to get too into everything, but what this actually will be as I write the program will just be a file, which again, that's a basic type of document in an operating system. It's probably defined by the operating system itself. I think it would have to be. And this type of file will have a certain extension that tells it some information about what to do with that. So the extension for this one will be .cs. So like if I call this maybe my program .cs, the .cs will tell the system that this file represents some source code for C#. And actually, I'm not going to write this in C#. I'm literally just going to write it in like pseudocode because I think that will be faster and actually more helpful for the big picture, which is what I'm trying to illustrate. So then this will get, it's going to have some header information, which they're going to be called like, I think they would be called namespaces. So it'd be like, it used the word using. So using system, for example, and I'm gonna just call that header information. The important thing, whether I got the right word or not, is what this represents. So what happens then with this file, which will have a bunch of other text in here, I didn't put it in yet, but this file is just text. The computer can't do anything with it. Once again, just to drive home the point, the file is just a chunk of ones and zeros inside the ROM here, but it has different kinds of tags, flags, information that tell the rest of the system what to do with it. And the tags and flags and whatever else for this particular file will tell it that it's a C# source file and that it's a file. But that's not usually what you want it to end with, because like say if you're writing a console project and you're writing like a hello world where you want the console to pop up and just print to the screen the words hello world, then it will have to know that that's what it's supposed to do with that information. So what happens is you compile it, and you compile it, once again, my whole point for making this is to really stress that everything on the computer is just space in memory. Almost everything we think about on the computer is really just space in memory. So there's space in memory called a compiler. The compiler passes through all these other layers. So once again, you have the operating system, which includes the kernel, some memory assignment stuff, the scheduler. It's interacting with the CPU and with these other hardware devices, and it's pushing uh, data to the registers, which are pushing the data through the ALU, the arithmetic logic unit, and performing calculations and spitting data back out and filling in new information into the ones and zeros. And that's what's going on. Well, this is just, the operating system is just the ones and zeros storage, but it's telling it how to act a certain way. Then the compiler is just ones and zeros storage, but it's going through the ones and zeros storage, it's intermingling and mixing with this from the operating system. And then, or I guess that's kind of right. I don't know that it's actually intermingling. I think that's probably the wrong illustration, but a little piece of this will go in to say, grab a little piece of this. A little piece of this, then we'll say to grab a little piece of this. I think that's probably a more accurate picture of what's happening. Then it spits things out. Then it's ready for another piece. So it wants the next piece of the source code here, this .cs text file, as you're compiling it. That's the process I'm describing. So you have the operating system will say, okay, what are we doing now? Oh, we're compiling. Let me grab a little piece of the code that's part of the compiler. Okay, I grab that little piece of code. That little piece of code from the compiler says, okay, grab a new little piece of code from the file. Okay, grab that new little piece of code. Smash that stuff through the registers and the ALU, pump it back out, and write some new ones and zeros at certain locations inside the ROM here, and these ones and zeros. Once again, and maybe it would be the RAM, but whatever, it's not my point. So that's what's going on. When the compiler is done, it changes what's the ones and zeros are arranged in a certain format that represent, hey, this is a text file, use this the way that you use a text file. After the ones and zeros are rearranged, it will have an executable file So .exe, so it would have a name. It doesn't have to be the same name, but I'm just gonna make the same name. So it'd be my program.exe, and often the .exe part is hidden from you, but it's there if you open up properties. So now the .exe will be a new set of ones and zeros inside here, inside the ROM, maybe in the RAM. Once again, it's not my point. So maybe in the ROM here, you have a new set of ones and zeros. That's the myprogram.exe. Now, when you interact with that, it will do different stuff. So say if I double click on this right here, well, I have my operating system is already running. My operating system will be sending through some information to the registers, to the ALU. It will read the mouse at the appropriate point and say, oh, wait, that guy clicked the mouse. What do I do with that? Oh, he didn't just click it once, he did a double click. Oh, what do I do with that? And then that will say, oh, well, what kind of file is it? Oh, it's an exe file. Well, since it's an exe file and you double clicked on it, you need to open it up and run it. So now when you open this up and run it, now it's not just text anymore. The ones and zeros that are in this new place in memory, because you didn't erase this first one, the .cs file still exists, but we're not using that now. We're using this separate place in memory that's the .exe file. And it says, okay, now that the .exe file is running, if you double clicked on it and you wrote your program right, it's going to open up with a window that says, you know, prints the text hello world on it. And if you did it right, it'll just sit there. If you didn't do it right, it'll close right away. But it's so fast that you probably won't even be able to see it. So there's some of that. Now, the next thing that I want to talk about, I was going to fill this in, but I see I'm already taking up a lot of time. I think I will fill it in, but what I want to fill it in with is, so you're going to have using system, take a step back. So using system then, when the compiler does its compilation thing, there's already a bunch of chunks of code that are setting aside somewhere, again, just ones and zeros sitting aside somewhere on ROM. Then when the compiler runs, when you put using system, it'll say, oh, there's a chunk of memory that represents system, and I need you to grab that chunk of memory called system and incorporate that into the ones and zeros that are going to be populated from the rest of the code that I write. And then another thing would be, and this is where I'll probably get some of the code wrong here, so I think it'd be like namespace, my program. I don't remember if you need, I think you use these. That's what's there. And then inside of that will be, where's my cursor? Some spaces, say like class. I think you need public right here. So public class program. And then, shoot, that's going to be hard to do with in this format. Dang, none of the keys that I want to do work. Okay, so, and I just broke my, can I type? Shoot, I just got rid of it. Okay, well, anyway, I'm not going to type it out exact. It's going to be real hard to do in Paint. Basically, though, you have a thing, you're going to end up creating something called a namespace, which just is like a collection to hold the stuff. Okay, system was a collection of ones and zeros that existed outside of your program that you're pulling in to your program. Namespace is a collection that's inside here, not outside. Then you're going to have inside of here, you're going to create a class. You'll have to create, typically you give the class the same name as your thing that you're doing. So actually I'd probably call this one my program. I don't know, I like calling it program. That's pretty common, I think. So you're going to create a class, maybe we'll call it program. And then inside of program, you're going to have, at the very least, you have to have a place where there is a main method. And once again, I think it needs to be capitalized, but I'm just going to intentionally make this real trash. You have to put arguments inside here, but I'm going to leave those out. So you have this thing in there called a main method, and then inside of here will be places where it calls all the classes you're going to write, which will often be in another file somewhere else. So class 2, class 3, and so on. And then there's a thing to signify to end the program, which is going to be a right brace, but I'll just do it that because this is kind of like pseudocode at this point, very much pseudocode at this point. So anyway, my whole point is to say this is going to be like a C# program, and there will be other places where these classes will exist, which are going to be other files. So let's do, here would be the text that represents class 1. Here would be a text file that represents class 2, a text file that represents class 3, and so on. Class 1, class 2, class 3, and when you compile this, the way the compiler works, so now we're getting into the importance of how this particular compiler works. There's different kinds of compilers, and there are other ways to write code that is not compilers. And this is probably about where I'm going to end up stopping the video. Networking would also be interesting to talk about, but I think it's going to kind of take a, I'm basically going to have to erase everything and redraw, and so I probably won't do that. But uh, with this part here, so when you compile this program, it pulls the ones and zeros that were from the namespace area. It pulls the ones and zeros from the classes that are from other files. It pulls, then it starts, they always say it this way, it starts program execution with this main method. So this has to be included. And typically what this does is calls your other classes. It works as kind of like your backbone for your program. And it will, so for example, if you're using all three of these classes in this order, it will call class 1. So that's going to take the ones and zeros that were kind of written out, not as ones and zeros, but they were written out in C# that got turned into ones and zeros. It's going to take those and jam them in here sequentially. Then it's going to take the ones and zeros that come out of this class 2 and jam them into here, the next position. Then it's going to take the ones and zeros that come out of class 3, jam them into here, and assuming that I'm kind of ignoring loops and whatever other types of things like that, if there's nothing else, it will end the program, and the program will actually stop running if you didn't put anything in there to keep it looping, because it's not really fully sequentially. Things can loop, but anyway, that's enough for right there. And so this is an example of how you could make a program roughly using C#, which is terrible pseudocode is how I designed it, how I made it there. But again, my point is just to show how a computer works. So I showed pretty well how the hardware is set up and how it works. And there's people that write the program that goes on the BIOS, and there's people that write the program that goes for the operating system. But after that, almost everybody that writes programs that gets handled by the operating system. And they write those programs kind of more or less in the fashion that I showed here. And this could turn into a text editor. This could turn into a browser. This could turn into a game. And when you have this program converted to the .exe format, that's when you see it to where you can double click on it, open it up, and it does its thing the way that we think of applications typically doing their thing. And their thing then is just, again, it's just a set of space that's carved out in memory that when it's active, the operating system will grab the certain chunks of code from that, certain ones and zeros, jam them in to the, well, maybe to the RAM. I think they might already be in the RAM because if it's active, I think it has to be in the RAM. That's where I'm not really sure about how RAM works in like runtime. But anyway, so let's say they're already in the RAM because it's running the program. uh, then it will have to, it almost certainly couldn't fit everything in RAM. So sometimes there will be stuff in RAM, and sometimes it will say, hey, I need you to grab the next set of stuff from ROM and put it in RAM. So it will do that. Sometimes if it's already in RAM, it will say, I need you to grab this certain line from RAM, shove it into this register, pull from some of these other input output devices, put those into the registers, do some math on them, spit out the output either to an output device or to a place in RAM. Then if it's in RAM, I probably has to go from RAM to ROM. I'm not sure. Maybe it can go straight from the CPU to ROM. I'm not sure about that. But anyway, that's kind of just a real basic understanding of how a computer works.